Let's move to question 16. A question which is very common in paper 1 under the topic measurements 2. The topic is very common in paper 1 physics. We are told, part A of the question, we are asked, what is the diameter of the circular disc given that the vernier calipers has a zero error of negative 0.02 centimeters. I'm assuming this is in centimeters simply because the length measured by the vernier calipers is always measured in centimeters. We want to make a reading from this. When making a reading from a vernier calipers, I want to expand this so that everybody can be able to see this clearly. How do we make a reading from a vernier calipers? There are two readings that we take from a vernier calipers. There is the main scale reading and there is the vernier scale reading. The main scale reading is taken from the point, just the point, from the point on the main scale just before the zero mark of the vernier scale. If you look at our diagram, this is the zero mark of the vernier scale. The point that just comes before that on the main scale, you can see that, which is 1 unit, 1 millimeter after 2 centimeters. So 1 millimeter after 2 centimeters, that is 2.1 centimeter. I can write that in 2 decimal places because the vernier scale measures distances to 2 decimal places. So this will be 2.10 centimeters. That's the main scale. And then the vernier scale, you count the number of divisions on the vernier scale up to the point where the two scales are coinciding. If you look at this, that point marks the point where the two scales are coinciding. So how many divisions do we have up to that point? This is 1, 2, 3, 4. We have 4 divisions. Remember, we count the divisions, the spaces in between. We have 4 divisions. So we take 4 times the least count, which is 0.01. That gives us 0.04 centimeters. So the vernier scale reading is 0.04 centimeters. When we combine the two, it gives us 2.14 centimeters. This is the reading from the vernier calipers that we have in this diagram. But now, remember, we were told something. We were told, what is the diameter of the circular disc given that the vernier calipers has a zero error of negative 0.02? Remember, all errors are subtracted from the reading to get the actual reading, the actual measurement of the object. So here we take 2.14 minus negative 0.02. We have 2.14 minus negative 0.02, which becomes positive. So we have 2.14 plus 0.02. That gives us 2.16 centimeters. So the diameter of that circular disc we have there is 2.16 centimeters. The second part of the question, that is part B, says, in an experiment to estimate the diameter of oil molecule, 100 drops of oil are released from a burette. We are told 100 drops of oil released from the burette. And level of oil in the burette changes from 0.5 cubic centimeters to 20.5 cubic centimeters. One of the drops is placed on water and spreads over a circular patch of diameter 20 centimeters. The first question, we are asked to determine the volume of the oil drop. The 20 drops that we have here, we are told 100 drops, not 20 drops, but 100 drops. They have a volume equal to 20.5 cubic centimeters minus 0.5 cubic centimeters, which gives you 20.0 cubic centimeters. That is the volume of 100 drops. So if 100 drops gives us 20.0 cubic centimeters, what will be the volume of one drop? Will it be equal to what? It will be 1 times 20.0 divided by 100. This 0 and this 0. 2 divided by 10, it gives you 0.2 cubic centimeters. That is the volume of one drop. Simply you take 20, you divide by 100. That will give you a volume of 0.2 cubic centimeters. Roman 2 of the question, we are asked to determine the area of the patch. Remember, the patch is in circular shape. That's our assumption when we do this experiment. The area of a circle whose diameter is 20 centimeters is as follows. Area is equal to pi r squared, which is equal to, our pi we can use 3.142 times the radius. You know, we are given the diameter is 20 centimeters. So 20 centimeters divided by 2, we get 10. Our radius is 10. So we multiply by 10 squared. That will give us 314.2 square centimeters. That is the area of this oil patch. Remember, when I have a drop, and then this drop, you know, a drop looks like that. This drop is placed on the water surface. It spreads until it becomes 1 molecule thick. 1 molecule thick. The oil patch formed is 1 molecule thick. So if I get this means this oil patch will look like this. The real shape of that is a cylinder, but the thickness or the height of that cylinder is 1 molecule. Meaning that if I can get the height of this cylinder, if I get the height of that cylinder, it means that will be the diameter of the oil molecule. How do we do that? Our other assumption is that the volume of the drop is equal to the volume of the patch. The volume of the drop already is calculated to be 0.2 cubic centimeters. So 0.2 is equal to the volume of the patch. Because the patch is in the shape of the cylinder, it is the base area times height. Our base area is 314.2 times the height. Our height is the diameter. So we divide by 314.2. We divide by 314.2. This will cancel that. Our diameter of that molecule will be equal to, when we divide 0.2 divided by 314.2, the answer is 6.365 times 10 raised power -4 centimeters.